Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create a Wellenkrug surface. In the next few videos, I will introduce some more 3D parametric surfaces. Firstly, in this video, I will explain how to use the parametric surface data function to create a Seashell surface. The Seashell surface is a type of conical surface. This surface can be described using this set of parametric equations. You can see here x, y, z coordinates can be expressed as a function of u and v. Here u is in the range of 0 and 6 pi. V is in the range of 0 and 2 pi. Here we will use the git tool to clone the source code used in the last video. Here is the download link at GitHub repository. From this link, you can download all the source code used in the last video. Now open a command prompt window and run the following command: git clone and paste this link. This will generate a WebGPU 29 folder on your local machine. This folder contains all the source code used in the last video. Now we want to change the name of the WebGPU 29 folder to GPU 30. Rename 30 and cd into this new folder. At this point, we are going to start Visual Studio Code with the command code period. This is Visual Studio Code interface. Now we can close this welcome page. Here contains all the source code used in the last video. Now open a new terminal window and run the command npm install to restore the npm packages used in this project. Okay, finished. Now all the installed packages are stored in the node modules folder. First, we need to add the new function to the mathfunc.ts file. From src folder, open mathfunc.ts file. Here we need to add a new function called Seashell. Here is the Seashell function. It takes u, v, and center as its input arguments. Here the center parameter lets you set the position of the Seashell surface. Inside this function, we define x, y, z as a function of u and v using these parametric equations. This function returns vector 3 point on the Seashell surface. Now we can save this file and close it. Next, we need to make some changes to the index.html file. From DRST folder, open this file. First, we need to change the 29 to 30 because this is 30th video series. Next, we need to change Wellenkrug surface to Seashell surface. The input parameters used here will be the same as those used in the last video, but we need to change the scale 1.5 to 2 to get a better default size. Now we can save this file. Next, we need to make some small changes to the main.ts file. From src folder, open main.ts file. Most code will be identical to that used in the last video, except here we need to replace the Wellenkrug function with Seashell function. Inside this create surface function, we also need to replace this Wellenkrug function with shell function. We also need to change the U range from 0 to 6 pi and V range from 0 to 2 pi, and change the division, V division from 100 to 200, V division from 50 to 40. We then need to reset the X and Z value range to -4, 4, -4, 4. Also, we need to change the default parameter from 1.5 to 2, and here also need to change to 2. Here we also use the scale Y, color map name as these functions, the input arguments. Or the other part of the code is the same as that used in the last video. With this framework set up and following the procedure presented here, you can easily create your own 3D parametric surfaces in your WebGPU applications by simply define your own parametric functions. Now we finish the modifications to the main.ts file. We can now save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to build our TypeScript code in production mode. npm run prod to bundle our code. Okay, the bundle file is created successfully. Now we can click the Go Live link to open Chrome Canary to view our Seashell surface. Click this link. Here is our Seashell surface with the default lighting and color map displayed on this page. Here the scale set the default size of the surface. For example, if we change it to 1, we will get a smaller Seashell surface. So change back to 2. And scale Y lets you set the aspect ratio of the surface. For example, let's change to 0.5. You get a short and fat the surface. Let's change back to 0. From this drop-down menu, you can change the color map. For example, this is Autumn, Balm, Cooper, Grace, Hot, HSV, Spring, Summer, or Winter. You can also change to default Jet color map. You can also click this camera control body. Then you can use your mouse to control the motion of the surface. You can see and rotate the surface. You can also zoom in and zoom out the surface. Then click animation. It will rotate continuously. You can see that in WebGPU, we can easily create a beautiful 3D surface with lighting and color map effects. Now we have completed this example. In next video, I will show you how to create a silvered animal surface with both the lighting and color map effects. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.